This looks like a fun one. Determine the value of k such that the line f at x equals 3x plus k intersects the quadratic function g of x equals 5x squared minus 2x plus 7 at one point. So, we are given our two equations, f at x and g at x. We're trying to solve for the unknown value k, so we're first going to make f at x equal to g of x to show that they are intersecting. So 3x plus k is equal to 5x squared minus 2x plus 7. Next what we're going to do is bring this 3x and k onto the other side of the equal sign and combine like terms. So we will get 5x squared minus 5x from the negative 2x minus the 3x plus 7 minus k. Now where do we go from here? Maybe we can try factoring it. 5x times x gives us 5x squared, but then how would we factor 7 minus k? Clearly this isn't going to work and we're going to have to use something else. What other information are we given? Well, we are told that these two functions intersect at one point. From here, we can use the discriminant, which is basically just the quadratic formula. Negative b plus and minus the square root of b squared minus 4 times a times c all divided by 2a. The discriminant is this part of the formula inside of the square root. Now using this discriminant, we can actually determine how many possible solutions there could be for a function. Let's say the discriminant equaled 4. Taking the square root of 4, we would get 2. Or rather we would get positive or negative 2. Meaning that when our discriminant is greater than 0, there are going to be two solutions, whether we add or subtract 2 from the equation. Solutions can also mean intercepts. So if the number is greater than 0, that means there are two interceptions. But what if the discriminant is less than 0? Say it was negative 1. We can't take the square root of negative numbers. This would result in imaginary numbers, which doesn't help us. So in this case, we'll get no solutions. But what if the discriminant is equal to 0? Well, taking the square root of 0 is just 0, and there can't be positive or negative 0, only 0. So there would be one solution, or one interception. And since we know that these functions intercept at one point, the discriminant b squared minus 4 times a times c is equal to 0. Now from our equation, 5 is our a value, negative 5 is our b value, and 7 minus k is our c value. So for b squared, it's negative 5 squared minus 4 times 5, which is our a value, times c, which is 7 minus k, is all equal to 0. Let's simplify. Then negative 5 squared will equal 25, and we can FOIL this 5 into this 7 minus k bracket to make it 25 minus 4 times 35 minus 5k. Next we can FOIL this negative 4 into this bracket, giving us 25 minus 140 plus 20k. 25 minus 140 is negative 115, but when we bring it onto the other side of the equal sign, it equals positive 115. And now to isolate for k, we can divide both sides by 20, making k equal to 115 over 20, or if we reduce it, k equals 23 over 4. You're not always going to get a polished number like 2, but just to confirm that we have the right answer, let's plug it back into the equation as k. So 25 minus 4 times 5 times 7 minus k, or 28 over 4 minus 23 over 4. This equals 25 minus 4 times 5 times 5 over 4, and then if we multiply 4 over 5 by 5, we get 25 minus 4 times 25 over 4, and these 4's cancel out to give us 25 minus 25, which equals 0, proving that our answer is correct. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.